Yes. Analyzing graphs. That's kind of the last thing we're looking at, and piecewise functions. So the first thing we're going to do is we're going to analyze graphs, and then after we finish analyzing graphs, we'll look at piecewise functions. Now, graphs can show the relationship between quantities without specific numbers on the axis. So here it has distance and time. So we can still show a relationship between distance and time without actually having numbers for time or numbers for distance. So we can still look at it. So if we look at this graph, we can see here the first part of it is increasing because it's going up. And then it's constant because it's not increasing or decreasing. It's a flat line. And then the last part, it is decreasing, yes? Now, we can also say that because these are straight lines, it's a constant. So at first, it's increasing at a constant rate because it's not increasing faster or slower. It's increasing constantly. Because a curve would be increasing at a faster rate because it's going up faster and faster. So if it's a straight line, it's increasing at a constant rate. If it's more of a curve up or curve down, it's increasing at a faster rate. So when we kind of look at this first one here, A. So as we're moving from left to right, well, at first, what is the graph doing? It's increasing at a constant rate, yes? So at first, so it increased at a constant rate. Then what happened? Then it increased faster. We can say increase faster at a constant rate or increase faster, yes? Because it was increasing at a constant rate, then it increased faster at a constant rate. Then what did it do next? And then it decreased. And then it decreased at a constant rate. And the reason we say constant rate is because we're dealing with straight lines. It's not curved. That's it. That's all we have to do for A. Questions on this here? We finished writing down A. Okay, let's look at B. So let's describe how the graph went. So it starts here in what? It's not changing, right? So the first part of this graph, it was kind of a constant rate because it has a constant rate. We're not increasing, we're not decreasing. It's a constant rate. It's constant. Then what happens? Then it decreased. At a constant rate or a decrease down. Or really, actually, I'm going to, because we had really, let me rephrase the first one. Let's say no change. I don't know why, but I just didn't, once I thought about that, I didn't like the constant rate. Because there's really no change at the start. Yes? Because it's not going up, it's not going down. I would just say no change, you can add it in there. But there's no change. Then we decreased at a constant rate. And what was that followed by after we decreased at a constant rate? We increased at a, then it increased at a constant rate. Any questions on this here? Yep. Okay. Yeah. Let's look at the next one. So let's look at C. So starting here, what happens first? We increase a constant, right? Then no change. And as y'all notice, I grabbed the book because I wanted to see what they said. What do they normally say about second guessing yourself? You're normally right if you got it the first time. And guess what the book calls this part here in the middle? They're saying it's no change. That we remained at this kind of constant rate. It was constant. Is what they will call it is a horizontal line segment. Increased at a constant rate, then it stayed constant, no change, or we can say either this here or stayed constant, because I want to make sure, because again, it's going to ask this on the homework. It kind of stayed constant for that amount. Then what did it do? Then decreased at a constant rate. So it increased, stayed constant, and then decreased at a constant rate. Questions on this here? We like this here? Yes? Let's look at the last one. So what happened first? It increased at a constant rate. Increased at a constant rate. We'll say constant rate. Then what happened? It at a constant rate. Then what happened next? No change or stayed constant. And lastly, constant rate. And that's it. So you'll have questions on the homework assignment asking about this. How did it increase? What is it doing? There's going to be some parts where it's got the graph color-coded. A, B, C. Which one is increasing at a constant rate? You've got to pick it. Which one's increasing at a non-constant rate? So when we talk about a curve. Let me do that. Looking at this graph here, this isn't in your notes. What would we describe this graph? What would this graph be doing? It'd be decreasing. Because it's decreasing now, it actually works out that we could say that it's continuing to decrease. It's just decreasing at a smaller amount, but it is decreasing. But this isn't at a constant rate. Because if we look at any 2 points, so let's just say these 2 points here. Is the decrease between these 2 points the same as these two? No, so it's not constant, but it is continuing to decrease, just at a slower and slower rate, yes? Okay, let's look at another one. So here, it's increasing up to this point, yes? But would we consider this constant? Well, no, because it's increasing faster, then it slows down, and then it speeds up. So it's going up and down, yes? And this is above what we're going to do, but this here and this here, they're called turning points. Why do you think we would make a significant term for those? Because what's happening at those points? It's doing what? It's changing from and then decreasing to. And it's called a turning point. Kind of interesting. How many of y'all have ridden a horse or ridden kind of any animal? Yes? Y'all know what a saddle is? A three-dimensional turning point is actually three-dimensional turning point is actually called a saddle point. Because on one side of the graph, it's going from decreasing to increasing, and then the other way is actually going from increasing to decreasing. So it actually looks like a saddle, three-dimensionally. So they call it a saddle point. But that's above and beyond what we'll cover. Because most likely you won't see a graphical saddle point or cover one in high school. You'll cover it in college if you go into upper degree math, go into a math field. Okay. That brings us to the last part here, piecewise functions. Piecewise functions is a function that is defined by more than one expression. Whoa. So we can have more than one expression, and there are some stipulations to them. There are some inequalities that define x. Now it's going to be make a little bit more sense if we just kind of look at this here. Our first one is this here. F of x equals x minus 2 if x is less than or equal to 0, and 2x plus 1 if x is greater than 0. So what this is talking about and what we're referring to, and it's mainly all based off this here, these two stipulations. Because if the value of x that we're plugging in is less than or equal to 0, we use the top equation. So if this statement is true, then we use this. If this statement is true, then we use the other one. It's all dependent on the value of x, what it makes true. So let's look at an example. X is 0. So we're talking about f of 0. So which one of these two would be true for 0? So if x is 0, is it less than or equal to 0 or greater than 0? Well, it'd be equal to it, wouldn't it? So this top statement here would be true, yes? So since that statement's true, I'm going to be plugging it into x minus 2. Is whichever statement our value of x makes true is going to be the equation we use. So for 0, I'm going to be using x minus 2. And we're going to plug 0 in for x. So we'd have what? 0 minus 2, which is? Any questions on this here? So since 0 satisfied that first inequality, we use the equation that attached with it. So let's look at the next one, f of 4. Now, is 4 less than or equal to 0? Well, no. 4 is. So that satisfies the second equation, this here, yes? So I'm going to be using 2x plus 1. So I'm going to be using 2x plus 1. So this time the value of x is 4. So since it satisfied the bottom inequality, I'm going to use the bottom equation. Well, 2 times 4 is 8 plus 1 is. So f of 4 is 9. F of 0 was negative 2. Questions on this here? Any questions on any of this here so far? We're ready for the next one. Okay. There we go. So let's look at the first one, f of negative 8. So this one here, the value of x is negative 8, yes? So we want to look at the 3 inequalities that we have, because this one has 3, and see which one does negative 8 make true. Is negative 8 less than negative 2, between negative 2 and 5, or greater than 5? Well, negative 8 is smallest, yes? It'd be less than negative 2, yes? So which one does it make true? It makes the top one true, yes? So f of x, so we're using the equation 3, yes? Is there an x in there? No. So f of x is just 3. Right. So 0 is between these two here, yes? So it makes the middle one true. So I'm going to be using x plus 2. So for f of 0, we're using x plus 2, and I'm plugging in 0 for x. So it would be 0 plus 2, which is? So f of 0 is 2. Now, because it is equal to, for 5, we still use our x plus 2. So f of 5 would equal 5 plus 2. So f of 5 would equal 7. 5 plus 2 would give us 7. Are there any questions on this here? Have y'all done these before? This one here we'll be using the 4x because 10 satisfies this bottom one where x is greater than 5. So here we'll do f of 10, which would be 4 times 10, and 4 times 10 would give us 40. Questions on this here? Any questions on anything we've done so far? Are you ready for the next one? I think I'm going to throw that on the floor. So negative 4. it makes the top inequality true, yes? So that means I'm going to use the top equation for it. I'm going to be using the negative x plus 4. Since we have g of negative 4, I'm going to plug in negative 4 for x. Well, negative 4 is a positive, and 4 plus 4 is a negative, and negative would give us a positive. It makes the middle equation statement true, yes? It's between negative 1 and 2. Well, here it's just 3, isn't it? Just be 3. So 5 makes the last inequality true. Because it's all dependent on which inequality is it making true, and the one that it is the statement we'll use. So here's 2x minus 5. And we'll plug 5 in for x, so we have 2 times 5 minus 5. Well, 2 times 5 is, and 10 minus 5 is 5. Any questions on this here? And that's it, yes? Now this here, piecewise functions, I have a feeling it seems like one of the ones that wouldn't be, because most things in mathematics that you learn in school here, or learn in school, don't have a lot of function or application. Piecewise functions actually show up a lot. How many of y'all have been a part of or know or have heard someone bulk order anything? Y'all know about bulk ordering? Bulk ordering a big size. Because they talk about if you order t-shirts, because they do this a lot with t-shirts. But if we get at least 30 t-shirts or order 30 t-shirts, we'll get a discount. Because most companies will tell you if we'll sell them $20 a shirt if you order between 0 and 20. If you order 20 shirts or less than 20 shirts, it's going to cost you $20 a shirt. Well, if you order between 21 and 30 shirts, so you're going to write it this way. If you order between 20 and 30 shirts, it'll be $18. It'll be $16 for each shirt if you order between 30 and 40 shirts. But this here, well, you're paying $16 per shirt. Yeah, because normally when you're talking about these here, you're talking about kind of shirts like this. So when they do for the playoff shirts that just came out, the more shirts that they can get ordered or people to order, they get a better deal for each shirt. Because if they're actually already done the design, the printing, the ink, it's cheaper to do more of them. It cuts down on their costs. So they'll do that on shirts, or most bulk order items will use a piecewise function for it. But that is it for today.